For today's STAR skill, we're going to focus on radicals. On page 1, the instructions are to simplify each radical expression. If necessary, use absolute value signs. Our goal is to find factors for the numbers and variables under the radical where as many as possible are perfect squares. That way we can take the square root of them and move them out from under the radical. To get started with number 1, 704 can be thought of as 64 times 11. And then Q stays the same. So now the square root of 64 is 8, and we can combine the 11Q back under the radical. So now we've made these numbers much smaller and easier to understand by changing the square root of 704Q into 8 times the square root of 11Q. And this is our final answer. For number 6, the square root of 72 can be thought of as the square root of 36 times the square root of 2. The square root of 36 is 6, and we leave the square root of 2. And our final answer is 6 square root of 2. Number 2. Square root of 25z squared can be thought of as the square root of 25 times the square root of z squared. Square root of 25 is 5, and the square root of z squared is z. So our final answer is 5z. Number 7. 320 can be thought of as 64 times 5. Y to the third can be thought of as y squared times y, and b stays the same. Now, the square root of 64 is 8. The square root of y squared is y, and we can combine 5yb back under the radical. So our final answer is 8y times the square root of 5yb. Number 3. 28 can be thought of as 4 times 7, and g to the fifth can be thought of as g to the fourth times g. Square root of 4 is 2, and square root of g to the fourth is g squared. And now we can combine the 7g under the radical. And our final answer is 2g squared, square root of 7g. Number 8. 405 can be thought of as 81 times 5, and p to the third can be thought of as p squared times p. Square root of 81 is 9, and the square root of p squared is p. Then we combine 5p s under the radical, and our final answer is 9p times the square root of 5ps. Number 4. 539 can be thought of as 49 times 11. M to the fifth can be thought of as m to the fourth times m, and h to the fifth can be thought of as h to the fourth times h. The square root of 49 is 7. The square root of m to the fourth is m squared, and the square root of h to the fourth is h squared. And then we can combine the 11mh under the radical. And our final answer is 7 times m squared times h squared times the square root of 11mh. Number 9. The square root of 12 is the square root of 4 times the square root of 3. And the square root of g to the fifth is the square root of g to the fourth times the square root of g. The square root of 4 is 2. The square root of g to the fourth is g squared. And then we combine 3g under the radical. So our final answer is 2g squared times the square root of 3g. And the final two problems on page 1. The square root of 28 is the square root of 4 times the square root of 7. And the square root of 4 is 2. So our final answer is 2 square root of 7. And our final problem, number 10. The square root of 27 is the square root of 9 times the square root of 3, and we have the square root of m. The square root of 9 is 3, and we combine the 3m under the radical. So our final answer is 3 times the square root of 3m. If you have any questions about how to simplify radicals, please use class time to ask for further clarification. Page 2. Adding and subtracting radical expressions. Simplify the radical expressions. So when we add or subtract radical expressions, first the radicals must be identical. As long as they are identical, you can add or subtract them by adding and subtracting their coefficients. So number 1, we have square root of 5 minus square root of 5. The radicals are the same, so this is 1 minus 1, which equals 0. And that makes sense because anything minus itself equals 0. Number 6, all the radicals are square root of 3. So what we're really doing is negative 2 plus 5 plus 7. Negative 2 plus 5 is 3, and 3 plus 7 is 10. So our final answer is 10 square root of 3. Number 2. These are all square root of 3. So what we have is negative 2 plus 5 minus 7. Negative 2 plus 5 is 3. 3 minus 7 is negative 4. So our final answer is negative 4 times the square root of 3. Number 7. These are all square root of 5. We can combine them. When you don't see a coefficient, it's understood to be 1. So this is 1 minus 1 minus 1. 1 minus 1 is 0. 0 minus 1 is negative 1. So our answer is negative square root of 5. Number 3. These are both square root of 6, so we can combine them. This is negative 1 plus 1, and that equals 0. So our final answer is 0. Number 8. we have square root of 5 and square root of 5, so we can combine them. This is 5 minus 8, which equals negative 3. So our final answer is negative 3 times the square root of 5. Number 4. These are all square root of 2, so we can combine them. So we have 6 minus 2 minus 1. 6 minus 2 is 4, and 4 minus 1 is 3. So our final answer is 3 square root of 2. Number 9. These are both square root of 5, so we can combine them. We have negative 1 minus 1, which equals negative 2. So our final answer is negative 2 square root of 5. Number 5. These are both square root of 3, so we can combine them. This is negative 1 plus 1, which equals 0. So our final answer is 0. And our final problem on page 2, these are both square root of 2, so they can be combined. This becomes negative 2 minus 3, which equals negative 5. So our final answer is negative 5 square root of 2. If you have any questions about how to add and subtract radicals, please use class time to ask for further clarification. Page number 3, multiplying radical expressions. Simplify the radical expressions. So first, what we can do is simplify the radicals. We'll leave negative 7, but the square root of 112 is the square root of 16 times the square root of 7 times the square root of b. And this is multiplied by the square root of 9 times the square root of 2 times the square root of b. Square root of 16 is 4. The square root of 9 is 3. The square root of b times the square root of b is b. And then square root of 7 times the square root of 2 becomes the square root of 14. So negative 7 times 4 is negative 28. Negative 28 times 3 is negative 84. B, square root of 14 is our final answer. Number 6. We have negative square root of 44 is the square root of 4 times the square root of 11. And the square root of 112 is the square root of 16 times the square root of 7. The square root of 4 is 2. And the square root of 16 is 4. Negative 2 times negative 4 is 8. And 11 times 7 is 77. So our final answer is 8 square root of 77. Number 2. Square root of 12 is square root of 4 times the square root of 3. Square root of 112 is square root of 16 times square root of 7. The square root of 4 is 2. The square root of 16 is 4. 2 times negative 4 is negative 8. And the square root of 3 times the square root of 7 is the square root of 21. So our final answer is negative 8 times the square root of 21. Number 7. The square root of 28n is the square root of 4 times the square root of 7 times the square root of n. The square root of 99n is the square root of 9 times the square root of 11 times the square root of n. The square root of 4 is 2. Square root of 9 is 3. Negative 4 times 2 is negative 8. Negative 8 times 6 is negative 48. And negative 48 times 3 is negative 144. Square root of n times the square root of n is n, and the square root of 7 times the square root of 11 is the square root of 77. So our final answer is negative 144n times the square root of 77. Number 3. The square root of 80d can be written as the square root of 16 times the square root of 5 times the square root of d. And the square root of 12d can be written as the square root of 4 times the square root of 3 times the square root of d. The square root of 16 is 4. And the square root of 4 is 2. Negative 4 times negative 2 is positive 8. The square root of d times the square root of d is d, and the square root of 5 times the square root of 3 is the square root of 15. So the final answer is 8d times the square root of 15. Number 8. The square root of 63p can be rewritten as the square root of 9 times the square root of 7 times the square root of p. And the square root of 44p can be rewritten as the square root of 4 times the square root of 11 times the square root of p. The square root of 9 is 3. The square root of 4 is 2. Negative 4 times 3 is negative 12. Negative 12 times 5 is negative 60. And negative 60 times 2 is negative 120. The square root of p times the square root of p is p. And the square root of 7 times the square root of 11 is the square root of 77. So our final answer is negative 120p times the square root of 77. Number 4. The square root of 28 is the square root of 4 times the square root of 7. And the square root of 80 is the square root of 16 times the square root of 5. The square root of 4 is 2, and the square root of 16 is 4. Negative 2 times 4 is negative 8. And the square root of 7 times the square root of 5 is the square root of 35. So our final answer is negative 8 square root of 35. Number 9. The square root of 99 is the square root of 9 times the square root of 11. And the square root of 32 is the square root of 16 times the square root of 2. The square root of 9 is 3, and the square root of 16 is 4. 3 times 4 is 12, and square root of 11 times square root of 2 is square root of 22. So our final answer is 12 square root of 22. Number 5. The square root of 18h is the square root of 9 times the square root of 2 times the square root of h. And the square root of 12h is the square root of 4 times the square root of 3 times the square root of h. The square root of 9 is 3. The square root of 4 is 2. 3 times negative 2 is negative 6. The square root of h times the square root of h is h. And the square root of 2 times the square root of 3 is the square root of 6. So our final answer is negative 6h times the square root of 6. Our final problem on page 3, number 10. The square root of 176 is the square root of 16 times the square root of 11. And the square root of 20 is the square root of 4 times the square root of 5. The square root of 16 is 4. The square root of 4 is 2. Now negative 5 times 4 is negative 20. Negative 20 times negative 6 is positive 120. And 120 times 2 is 240. And the square root of 11 times the square root of 5 is the square root of 55. So our final answer is 240 times the square root of 55. If you have any questions about how to multiply radicals, please use class time to ask for further clarification. Page 4, Dividing Radical Expressions. Simplify the radical expressions. So first, what I notice on the top, the square root of 55b squared is the square root of 11 times the square root of 5 times the square root of b squared. And on the bottom, the square root of 44b is the square root of 11 times the square root of 4 times the square root of b. The square root of 11 on the top and the square root of 11 on the bottom cancel each other out. The square root of b squared is b. On the bottom, the square root of 4 is 2. So now on the top we have 6b times the square root of 5, and on the bottom we have 10 times the square root of b. 2 goes into 6 3 times, and 2 goes into 10 5 times. We don't want to leave a radical in the denominator, so we're going to multiply the top and the bottom by the square root of b. So this gets us 3b square root of 5b on top and on the bottom we have 5b because the square root of b times the square root of b equals b. And now the b on top and the b on bottom cancel each other out. So our final answer is 3 square root of 5 times b over 5. Number 5. On the top, the square root of 55h squared is the square root of 11 times the square root of 5 times the square root of h squared. And on the bottom, the square root of 20h is the square root of 4 times the square root of 5 times the square root of h. So here we have a square root of 5 on the top and the bottom that can cancel each other out. We have a square root of h on the bottom and a square root of h squared on the top. So this can eliminate one of the h's out of the top, and it can eliminate the square root of h on the bottom. Now we have the square root of 11 on top times the square root of h. That can be written as square root of 11h. And on the bottom, the square root of 4 is 2. So the final answer is square root of 11h divided by 2. Number 2. We have square root of 5 over square root of 7. We can't break these apart any farther, so the only thing to do is get rid of the square root on the bottom. To do that, we're going to multiply the top and the bottom by square root of 7. Because if you multiply by something over itself, you're really just multiplying by 1, and you're not changing the value. So square root of 5 times the square root of 7 becomes the square root of 35. And on the bottom, the square root of 7 times the square root of 7 becomes 7. So our final answer is square root of 35 over 7. On number 6, the top can be rewritten as 5 times the square root of 5 times the square root of 3. On the bottom, we can rewrite this as 2 times the square root of 9 times the square root of 3. We have a square root of 3 on top and a square root of 3 on the bottom that cancel each other out. So on the top, we have square root of 5 times 5, and on the bottom, the square root of 9 is 3. So our final answer ends up 5 times the square root of 5 divided by 6. Number 3. We can rewrite this as square root of 14 over square root of 14 times the square root of 2. The square root of 14 on top and the square root of 14 on the bottom cancel each other out. And this just becomes 1 over the square root of 2. Now we don't want to leave a square root in the denominator. So we're going to multiply the top and the bottom by square root of 2. We can do this because multiplying by something over itself is just multiplying by 1 and doesn't change the value. Now we have square root of 2 over 2, and that's our final answer. Number 7, we have a 4 on top and a 4 on bottom. Those cancel each other out. So now we have square root of 3 over square root of 5. But we don't want to leave a square root in the denominator. So we're going to multiply the top and bottom by square root of 5, because multiplying by anything over itself is just multiplying by 1 and doesn't change the value. Square root of 3 times square root of 5 is square root of 15. And square root of 5 times square root of 5 is 5. So our final answer is square root of 15 over 5. Number 4. Square root of 14 g squared can be rewritten as square root of 7 times the square root of 2 times the square root of g squared. The square root of 32g can be rewritten as the square root of 16 times the square root of 2 times the square root of g. We have a square root of 2 on top and a square root of 2 on the bottom, so they cancel each other out. We have a square root of g squared on top and a square root of g on the bottom, so it cancels out the 1 on the bottom and 1 of the g's on the top. And now when we rewrite this, we have square root of 7 times square root of g on top. That becomes square root of 7g. And on the bottom, the square root of 16 is 4. So our final answer is the square root of 7g divided by 4. And finally, number 8. This is the last problem in our worksheets today. We have 6 times the square root of 5 on top and 4 times the square root of 7 on the bottom. 2 goes into 6 3 times, and 2 goes into 4 twice. So now we have 3 times the square root of 5 over 2 times the square root of 7. But we don't want to leave a square root on the bottom. So we're going to multiply the top and bottom by square root of 7. We can do this because multiplying by anything over itself is just multiplying by 1 and does not change the value. Now, square root of 5 times the square root of 7 becomes square root of 35. Square root of 7 times square root of 7 becomes 7. So our final answer is 3 times the square root of 35 over 14. If you have any questions about how to simplify radicals, how to add and subtract with radicals, how to multiply radicals, or how to divide radicals, please use class time to ask for further clarification. You will need these skills on the STAR test, the PSAT, and the SAT. All 3 are now adaptive. So if you can't answer questions like these correctly, you won't be given a chance to answer higher level questions that raise your score.